Hello good people, welcome to another video. In this session, we are going to solve this volume by revolution problem. The question says, the shaded region in the figure is rotated about the line y equals to -2 to form a solid. And the two corresponding functions are also given in the graph. Now this question is asking us to set up a single integral for finding the volume of this solid. This shaded region is revolving about this line y equal to -2. First, let's draw that line. This is y equals to -2 line, and we are going to revolve this whole thing around y equal to -2 line. And now there is a very important observation we need to do. For this kind of problems, some people like to use washer method. Some people also like to use the shell method. But specifically for this problem, shell method is the perfect choice. Why is that? Because washer method will make a lot of complicacy for this problem. The first problem in the washer method is the first function is given as x equals y power 4 over 9 minus y squared over 2. If we want to use the washer method, we'll have to make the slices perpendicular to x-axis and then do the integration. And the integration should be in terms of x. So we will need to transform all the equations in terms of x. But the first function is not a straightforward polynomial function if we transform that in terms of x, and which will be a lot complicated to do the integration. So we are going to avoid the washer method here, and we will use the shell method. And to do shell method, we will make the slices parallel to our revolving axis. Let's say this is a random slice, and then we will revolve that around the revolving axis of y equal to -2, and that will give us a shell. And then we will revolve this slice. We will revolve this slice about the revolving axis y equal to -2, and that will give us a shell. And in such manner, we'll keep slicing the whole shaded region, and that will give us a lot of shells. And all the shells will be from the lowermost intersecting point to the uppermost intersecting point. That means we will need to find the intersecting points of these two curves. In such manner, we will keep slicing the whole shaded region from the lowermost intersecting point to the uppermost intersecting point. That means we will need to find the intersecting points of these two curves. Here both the functions of y are equal to x, so we can set this equation like that. We solve this equation and we would have 3 intersecting points, but we would only use 2 intersecting points because the whole shaded region is in the first and second quadrants. That means for the whole shaded region, y values are non-negative. So there will be no negative values of y in this shaded region. That's why we will ignore the negative root of this equation. Now let's find the volume of this equation. And for the shell method, when we are setting this up, the integration will be from the intersecting points y1 to y2. Now the integration of the surface area of shell in terms of y from the point y1 to y2. And we know the surface area of shell is 2 pi radius times height. And in this problem, the radius is along y-axis. But we need to find the radius from the revolving axis, which is 2 units below the x-axis. That's why we will need additional 2 units in the radius. Total radius will be y plus 2. And the height of the shell is the difference between these two curves. One thing we should notice that as we are setting the whole volume integral in terms of y, that means the difference of these two curves should be also in terms of y. That means the difference of these two curves should be a function of y. That's how We have the radius in terms of y, we have height in terms of y. Now we can do the integration. Now we can set the whole formula, and that will give us the volume of this shaded region when it is rotated about y equals to -2. That's all for today. See you in the next video. Thank you.